Hello everyone, this is Dr. Nirad Mehende explaining you my paper on FERC. So basically FERC stands for Facial Emotion Recognition using CNN. So if you see this particular paper is been published in Springer Nature Applied Science Journal, and what I have done in this paper is basically I am using two level of CNNs. The first level will classify each and every pixel in a picture as a part of your face or no face. So if you go by this standard, so let's say you have an image over here where you have a person, and then there is a background, maybe he's wearing some shirt or something like that, and then what happens is this particular network CNN tries to filter out all the background pixels so that only head this region will have logic 1 classification, like level 1, level 1, level 1. All the pixels in this region will be level 1 and outside will be level 0. So what you can say is it's a binary classification, and for that I use CNN, but nowadays there is another popular network which you all can definitely look for. It's called Pix to Pix. So this is a popular network which you can look for. So you have to give some ground truth images. Roughly I would suggest you can start with 200 images, and you can go up to 1 lakh images also, but I don't know whether you will get that kind of data set with you. But this is a roughly range in which you can start training your Pix to Pix. The only disadvantage with this kind of not using a CNN and using a pixel to pixel mapping is you need at least a 6 GB of graphics DDR memory and roughly 16 GB of DDR4 RAM. So if you have this much, and obviously maybe i7 or i9 or Ryzen 7 processor, should be good enough to start with the background removals. I will have this code of CNN maybe made publicly available, or it's on my website, so you can choose that code and try to figure out how you can use that particular CNN model to achieve the same. So Pix to Pix is a easier way, so those who are starting new can go for this directly. Pix to Pix is available in MATLAB, or you can choose another one also. Then let us see. So I have used initially I have used my own data set, but as the reviewer were asking me to add some standard database, I have added 3 of them, basically Caltech faces, CMU NEST, and then conc and expression. And then after that, if you see, so this is the proposed architectural diagram. So you have input from image or a frame of a video extracted, given to a background removal CNN which will have only face. Then we have face vector as mentioned over here. It's a 24-bit face vector. So instead of face vector, those who are familiar with deep learning, they can also go for deep metric learning. So deep metric learning is another technique which you can use. So here your metric is generated, which is roughly 128D encodings from an image of face. But if you don't want to go for that, you can go for the traditional image processing approach, that is detecting a double eye, then nose, then a ratio of double eye to nose, and then mapping of chin. So it all is a color based, or you can say histogram based, color histogram based mapping. And if you are not familiar with image processing, you can go for deep metric learning. Finally, these features are fed to a classification network where emotion is been predicted. So here is one way. I think this is the operation of how the convolution is carried out in the CNN, and then there is a different filters being applied, and then this is a vector that is being generated, and how the transforms such as rotation and distance has been corrected. And then finally, if you see, these are the some of the results. Now here if you see the accuracy for n equal to 25 and number of layers, so as the number of layer increases after roughly 4 layers of CNN, you will see the accuracy is slightly going down. So that is what we call the overfitting is happening. And again, if you see in another one where number of filters, they peak somewhere around 4. So 4 layer 4 filter is what we chose in this particular case. You can choose anything based on your metric. So since I had this 24-bit metric, I chose in this 4 layer 4 filter CNN for the classification of the mode. So you have this photograph, you have this face recognition output, and then you have this mode. Again, this photograph, this face recognition output, and then this mode. I hope my mouse is getting recorded. Then there is a comparison table with different methods in architecture, and then FERC compared with the standard network. So that's all, and if you have further queries, please feel free to write to me. I generally take time to respond because of lot of mails, but you can definitely write to me, and there is surely will be a response soon. So you can write to me at ninad@somaiya.edu, and if you are interested in carrying out this work further, we can work in collaboration also. So that's it. Thank you.
FERC stands for Facial Emotion Recognition Using Convolutional Neural Network, is the process of automatically recognizing the emotions based on facial expression of the person. 5 types of emotions FERC can recognize. These emotions are happy, sad, angry, surprised, feared. It is a project developed by Dr. Ninad Mahendale. The first neural network removes the background, and the second neural network uses a 24-digit emotion vector to determine the emotion. Feature vector is formed using Euclidean distance between eyes, nose, ears, etc. For any further details, contact Dr. Ninad. Thank you.